All right, today we're solving systems by substitution. Yesterday we solved them by graphing and using our calculator. Today a little bit an algebraic method called substitution. Here's the steps we're going to take. We're going to take one equation and solve it for one of its variables, either x or the y or a, b, whatever. We're going to take one of the variables and solve one of the equations. We actually did that in chapter 1, you may not remember. Then we're going to take that equation that we solved and we're going to substitute it into the other equation for that variable. And then after we get our first answer, we're going to substitute that answer into our first equation and solve it. Those are pretty complicated words, and it's really not that complicated of a process. Let me show it to you. Okay, so in this one we have 2x plus 5y equals negative 5 and x plus 3y equals 3. What I'm going to do is I'm going to take this variable. What I'm looking for every time is a variable that has 1 as a coefficient, because that makes it so much easier, and to be honest, it's really the only time to use this process if that is the case. So I'm going to solve for that variable, which means I'm moving a 3y to the other side, make it 3 minus 3y on the right hand side. And what I'm going to do is I'm going to use that expression right there, since that's what x equals, and I'm going to put it in to the x in the other equation. So I'm going to say 2 times 3 minus 3y plus the 5y equals negative 5. And again, that's what's called substitution, because I just substituted that in for the x. Distribute here, 6 minus 6y plus 5y equals negative 5. Negative 6y plus 5y is negative 1y equals negative 5. I'm moving the 6 over. That gives me negative 11 divided by negative 1. Y is 11. Now here's the beauty of substitution. One of the best things about it. Once you get your y is 11, you can plug it right back in there to get your x really quickly. So I'm just going to put the y. It says x equals 3 minus 3 times y. Well, y is 11. So that's 3 minus 33, which is negative 30 for my x. So my solution is negative 30, 11. And you can check that very easily. Just plug it in one of these two equations, and you should get that solution. It should work in both of them. That would be the point of intersection like we found yesterday. All right, let's try another one here. This time the y has the 1 as a coefficient, so I'm going to solve for the y, which means I'm moving the 3x over. Y equals 16 minus 3x, and I'm going to take that and put it in for this y right there. So it's going to look like 2x minus 3 times 16 minus 3x, and that equals negative 4. So I'm going to distribute the negative 3, make it negative 48 plus 9x equals negative 4. Have 11x minus 48 equals negative 4. If I move the 48 over, I get a 44, so that means x is 4. Now that's halfway, well, more than halfway. Once I get the x, I'm going to plug it right back here where we started. If I plug the 4 in there, it gives 16 minus 3 times 4, which is 16 minus 12, which is 4. So on that one, you get 4 for the x, 4 for the y, 4. And you can check that. Should be perfect. Okay, I think this may be a special case, but I want to check it out and see. There's one reason I must have put 3 of them on here, because I think 2 is enough. But again, find the variable with the 1. This is the y, so I can move the 3x over, and I would get positive 3x plus 7. Same step, substitute for that y, so I get 6x minus 2 times my new y is 3x plus 7 equals 5. Distribute the negative, make sure it's negative 2, make it negative 6x minus 14 equals 5. And here's what's weird about this one. The 6x's are gone. So it leaves me with this. It leaves me negative 14 equals 5. And what you have to do is you have to ask yourself, does negative 14 equal 5? Hopefully yourself will say, no, it doesn't. And if that's the case, then it's no solution. There's no answer. And remember, if it's a system, we call no solution. We call it inconsistent. That's our word for no solution. If I would have gotten negative 14 equals negative 14, if they would have been equal, that would have been infinite solution. So I'd have put consistent, dependent, but inconsistent because there's no solution. All right, that's all there is today. Just substitution, just that one process. Look for those special cases though, and I'll see you in class tomorrow. Look forward to it.